And as you might remember, first thing to do is always just spool up a machine so you can start working with it. It takes a couple of minutes to spool up, and in the meantime, we're gonna exchange some files so you can work on it, okay? So notebooks, and I'm gonna take, I'm gonna create I mean, I have a bunch of notebooks already created here, yeah? But let's go through the process completely so you can see how that works. Again, as a repetition, so you go to create notebook, yeah? You go and you type on fast AI, then you choose a machine. We're gonna just take a P4000 machine, should be sufficient for now. If your models get bigger, higher resolution, you can also go up into the P6000 area, but let's for now take the P4000. I'm gonna put a time limit here of 2 hours. Actually, yeah, let's put 2 hours, yeah. Don't forget always, when you're finished and you still have time on your machine, turn the machine off, yeah, because it continues charging. And then that should be all fine. We can leave this as is here and create a notebook. And it's gonna start spooling up. And while it's doing that, I'm gonna share with you some files. I'm using a dodecahedron, which has a higher resolution. And I have a bunch of nice style images. Go into the folder, and you will see there is 2 OBJ files in there now. One called dodecahedron 4 and another one called dodecahedron 5. Please download those. And then there is another folder here called styles, which you can also download. Let's go back to the Paperspace. So my computer is still proficient. And now it's running. Okay. I'm gonna just rename my notebook here and call it GD to GD 509 underscore 509, so that I know this is the one we spooled up for the course. And then, so it's a P4000. Then we have to go and start uploading those files that we just downloaded from the drive. So in the meantime, while we are waiting for the rest of the files to come, we can have a look into the GitHub repository and find actually the whole page for the 2D to 3D style transfer. So I'm gonna go into the GitHub repository here. So we're here in the Deep Design GitHub repository, yeah? And you remember that you have to scroll down to the model suite, this here. Yeah, here. That's what we need to go into. Yeah. So if you click on the model zoo, it gets you to all the different neural networks that we have already created and that are prepared to be used with the Paperspace. And you see there is the number 5. So last time we were looking into the 2D neural style transfer. This week we're looking to 2D to 3D style transfer. Here, number 6, sorry, number 6. 2D to 3D style transfer. And the 2D to 3D neural renderer for 2D to 3D style transfer, there's some explanation here where it originated. It originated in a paper by H. Kato, Y. Yoshiku, and T. Harada. From the University of Tokyo, who wrote a paper about this that describes also how to use it and how to basically create also the Python code for this, and that allowed us to create this shortcuts here for the Python code to be used in Paperspace. So what we need to look into here now is the neural renderer Docker container image, the workspace, and the command format and command example. And the command format basically defines what the command example is actually doing. So there's a bash run for 2D to 3D style transfer.sh. A bash is basically a collection of code and snippets of code that run together to execute a larger problem. And then you have to specify the path of the OBJ model. Yeah. And the input, so the input for the OBJ, then the input for the 2D for the image. So first for the model, then for the image. Yeah. Then you have to define the file name, the output directory, and then at the end you have the weights. Yeah. And we can see this in the command example. So bash run 2D style transfer.sh. So that's bash running the Python code. Then we have to define where is our OBJ file. And our OBJ file is in the storage folder, and there's a subfolder called 3D models. And in the 3D models, we have that OBJ file. We will put our dodecahedron in there, and we have to create a folder called 3D models. Yeah. I actually normally call this 3D underscore model. We're going to change that when we go through step by step. And then the next part is where is our image? So it is in the storage folder, and there's this in this file. The example is 2D model. So Alexa obviously created a folder called 2D models, where she put the image inside, which is going to be the style image for our process. However, we will rely here just on storage, styles, and then the image. So basically using the same lingo and process we used for the 2D style transfer, that's fine. We don't need that additional 2D models folder here. Then at the end, we have a space, and this is the name of the result. Yeah, so you name it here, you give it a name, yeah, of whatever you're gonna create here. And that image is going to be stored in the artifacts folder. Yeah, and in the results of the style. So there's another subdivision, go into the results 2D to the style transfer. And then at the end, we have the weights. So we're gonna go to and do this now in Paperspace. Back to the Paperspace console. So 2D to 3D 509 is running. And let's go to this purple tab on the right side and open it up. And here we should be able to see datasets, fastbook, and storage. Let's check out the storage here. And okay, the storage has my ImageNet DGG, which is important to have because all our code is there. And I already created here a folder called 3D models. So if you want to do that, what you need to do is basically go to the storage, and then you go here on the right side, there is a tab, little tab with an arrow called new. Yeah, and here you can create a new folder. Yeah. So when you click your new folder, you see it shows up here as untitled folder. Okay, if you want to change that name, yeah, untitled folder, let's go back here to storage. You can actually click on the in front of the untitled folder, and once you click there, you see that on the top here it says rename. And here you can give this folder a new name, 3D models. And you see mine is called 3D models, 3D underscore models. And you have to remember that, that's important, yeah? 3D underscore models, and models is in small letters, yeah? 3D underscore models. And then you rename it, that's it. And when you open up the 3D models, I already uploaded all the dodecahedron, but now you need to go to upload here on the upper right, yeah, and search for your OBJ, the dodecahedron 4 and the dodecahedron 5, and you upload those. And you see in the size of the models, if you see in the file size, you see that the dodecahedron has only 197 kilobytes, and the dodecahedron 5 has 826. The geometry of both is the same. The only difference is that the dodecahedron 5 is subdivided into more faces. That's why it becomes bigger. And it seems that the models with the higher resolution, definitely give you a better result in the 2D to 3D neural style transfer. Yeah. The lower the resolution is, the worse it gets. So I tried it with the dodecahedron 1, and you see here in dodecahedron 2, the dodecahedron 2 has 11 kilobytes, which is basically just a couple of faces, and you don't get a good result out of that. It looks not good at all. So the higher you go with the resolution, the better. However, of course, if you go higher with the resolution, it means longer calculation time, or eventually also we just will crash. Yeah. So you have to find the right balance. It seems that dodecahedron 5 works okay. I think that for the test now, we're probably going to go with the dodecahedron 4 because it calculates that quite quickly. So we may be able to see a result today already in the course. Good. So upload these 2 files. Yeah. And they should be then in your 3D models. Once you have that, let's go back to storage. And you remember styles. Yeah. Styles is where we uploaded all our images. And you see there's a bunch of images in here because I've been playing around a lot. That's where you upload the style image. And again, you go to upload, the upload button on the upper right. And I'm going to upload from my styles, maybe something different. Let's see. Yes. I have this one here. Let's take something colorful. Maybe this here. I would highly recommend to you guys, once this really works, I have the capital 2 anyways already. Once you have uploaded that and tried it out for the first time, I would really go and do very specific color images to test out how the model is affected through the neural network. So for example, creating a square image, which is diagonally divided with one side only being blue and one side only being red, or one side being black, one side being white, or a couple of diagonal stripes with different colors like green, blue, red, yellow, magenta, and so on. So just having a couple of stripes and then doing a style transfer with that, just to see how it's affecting the 3D model. And that will give you a better idea what colorations you're using, which colors your images must have in order to achieve specific results in the 3D models. All right. So both is uploaded now. That is great. Now we can start doing a job. Yeah, you remember? So you have to go to gradient, jobs. Yeah. And here are some of the successful examples that I tried recently with the 2D, 3D model. We're going to copy code from there, make sure that it works. So let's go and try the job builder. As you remember, so you go to the gradient, jobs, and then here on the right side, that blue tab, try the job builder. So we're going to create a new job. So we have to choose first a machine. Yeah, let's go to public and select again the here. And now that's where our content in the GitHub becomes important. So you see number 02 is the container. And I still have the deep design GitHub repository open. And here we are running 2D to 3D neural renderer for 2D to 3D style transfer. And here under this point, neural renderer Docker container image, that line here, copy, go back to the Paperspace console and copy it into the container line here. There we are. Okay. Number 3 is the workspace. Let's go back to the GitHub repository here, workspace. Let's copy that code here. And we're going to put this into the workspace. Workspace reference you can leave as is. And now here's where it's become interesting. Command line. Yeah. The command line here, yeah, this command line, there is somewhere a little problem here that really doesn't let it run properly. So we're going to use instead the code that I created last time around. I might have to go back here one more time through this, but this is my file 3D Goth high res, and we're gonna have a look into the code here. Just gonna hit on rerun, and I'm going to copy the command here and put it into the chat of our conversation. Okay, I'm pasting this into the chat, right? Okay, and now you see in the command, as we described it before, bash run 2D to 3D style transfer.sh, and then a space, which means we're going to the next part of the command. It has to find the 3D model in the storage in 3D models folder, and it's a dodecahedron, and I'm gonna use the dodecahedron 4 here, so I'm just gonna put 4 in here, yeah. And then you have a space, then comes the next part of the code, which defines where is our image, storage styles, and I think I'm gonna use, instead of a Gothic facade, I'm gonna use the cactus that we were just talking about before. So it's cactus 2, copy that here, and here. Make sure that it has .jpeg, .jpg, otherwise it doesn't work. Then we're gonna give it a name. Yeah, 2D Geo 3 Dodeca number 7, because it's a new one. And it's a GIF. And it's gonna go to the artifacts folder, and these are my weights now, which is 0.4, 2 E9, and 500 iterations. All right. Okay, so let's submit the job. Here we are, running. Oh, well, it's pending for now. So normally, if something is wrong, you get pretty quickly an error message. So within like 2, 3, maybe 4 minutes max. If it's running for 4 minutes and it's good, then it's probably okay, and you can let it run, and that should be. So that's basically for this. Now I'm going to show you an example of what the result is, what you get out of the process. So we're going to let this run for now, and you see in my list here there's the 2D 3D Goth high res image. Yeah, so I used here the higher resolution dodecahedron 5 to do this job. And you might remember that I told you that these little icons here between the machine type and the time when this was run, there is this little icon. Let me just point this out. Here, this one. Yeah. That's where you have to click to get to your folder with the artifacts. You see, this is also really good because you have a log here of what actually was running. And when you have an error, this is also a good area to see what's going wrong. So you will have a sense of where in the code there is the problem approximately, and then you can circle in the problem and solve it. Anyways, you see up here, this list here, we have the logs, which is the environment, the metrics, the files, and the artifacts. And we are for the moment interested into the artifacts folder. And you get this GIF, which is an animated GIF that shows your object rotating around. You might actually, for example, turn, before you export the OBJ, you could also turn the axis, so to have it more like you have planned it to be seen, because I actually wanted it to be a flat thing lying on the side. But of course, because of this continuous confusion of Z directions between different softwares, because some are up, some are into the Y direction, you get this mixed up stuff all the time. It happens. So you get that animated GIF, but you also get the OBJ. So here's the 2D geometry 3D Dodeca 6 OBJ, and you also have the shader, so the color. of your model. So you can actually export that too, and you could import both of them into Rhino or Maya, or wherever you want to use it, and look at it in a higher resolution. You can also render higher resolution, which gives you certainly the better imagery. And we get this here, which is the interpretation of the neural network of the image that you supplied for that model. Yeah, I used for this case an image called Gothic facade, which is basically a mirrored part of a Gothic facade that I just put on the model. And you can download this. So there's this little cloud here on the side, on the right side, which allows you to download your model to your computer or any one of those parts that you have here for that matter. Yeah. And let's open this up. Okay, do you see that?
Yes.
Yeah, so you see here the animated GIF of my 3D model. So it's a bit of a play now. Once you have run this process successfully, you can play around with the weights, like with the first number getting lower, the last number getting higher, vice versa, to see what is influencing what. Like when do I get more influence from the image versus when do I get more influence from the object, from the OBJ file. This is an interesting play. You will have to run it a couple of times, 4 or 5 times, to really get a feeling of how the numbers are influencing the result. You can also go really extreme in both directions and see what happens. But you can also count on when you overdo it with the numbers that you probably will crash the process. But that's part of learning what the boundaries are of the process and how to apply it best. Turn this off again. Let's check how the jobs are doing. So 4 minutes ago, it's still provisioned. Yeah. So it has not started running yet, but also I don't have yet an error message. Yeah. So it's also better at the beginning to use rather simple objects because it makes it easy for you to recognize what is influencing what. If you have a too complex 3D object, it becomes a little bit more difficult to understand what the process is actually doing. But once you have it, once you understand it and you see what's influencing what and in which way, you can basically start playing also around with other geometrical conditions, more complex ones. It's running. So mine is running. Be very careful with the code. You have to make sure that the models and the images are in the right folders. Yeah, that the spaces are right, because otherwise it just doesn't work. So I really recommend not to copy the code from the GitHub repository, not that example, really copy the one that I put in the chat. So I copied the one that is currently running. Yeah. So far I have not an error, so fingers crossed. Let's go back to the Paperspace, check if this is still running. Yes, it's still running. So I don't think I'm gonna get an error message here anymore. So this runs for a while, by the way. This is nothing, it's not, this will run now for 20, 30 minutes for sure, yeah, before you have a result. Yesterday, with the higher resolution model I used, the dodecahedron 5, it took almost an hour to run it, yeah. So you have to be patient there. Good. So we are pretty much now at the end for today. We have a couple of minutes left. Let me know if you have any questions or comments or ideas about the lecture you saw today, or if you have any problems with the process of running 2D to 3D style transfer, let me know. All right, sounds good. So if there is no further questions or comments, then I guess we can stop for today. And we talk soon again. Yeah.